sometimes when you're factoring, you need to apply more than one factoring method, or sometimes you need to apply the same factoring method more than one time. If you look at this problem, the first thing you should notice is that you have a GCF of 2. So we're going to pull that GCF out in front, and that's going to leave me with 16 x to the 4th minus y to the 4th. When I look at this, I notice I have a difference of perfect squares here. Okay, this is going to be a difference of squares. Okay, and what I notice is this 16x to the 4th can be 4x squared times 4x squared. And this y to the 4th is going to be y squared times negative y squared, one of each because it's a negative there. So if I go to factor this, I have my original GCF of 2. Then I'm going to have one of these 4x squareds and one of these y's in each parentheses. Okay? So what I've done here is I've taken this 4x and put it here, and this y squared and put it there. Now I need to do the second set of factors the same way. So I'm going to take the second 4x squared and this second y squared, although this one is a minus y squared. Okay, so essentially what I did is I took this 4x squared here and this y squared right here. What I want you to notice is that when I look at this factoring right here, this right here is a difference of squares again. Now my first binomial in this problem is not a difference of squares because it has an addition sign right here. And we can't do this kind of factoring if you have an addition problem. But we can when we have a subtraction problem with two perfect squares. So this 4x squared will break down to 2x times 2x. And the y squared on the right-hand side is going to be a y and a negative y. So when it comes to factoring, you've got your original GCF. You have this first set of factors we had when we did the perfect squares the first time. And then we've got the second set of factors, 2x plus y. And then we also have the 2x minus y for the second set of perfect squares that we had. So the final factored form answer for this problem, it's very long, we've got 2 times 4x squared plus y squared times 2x plus y times 2x minus y. And that is your final answer. Now, you can sometimes use the same factoring method more than once, but sometimes you have to use more than one factoring method. In this problem, we're going to use 3 different kinds of factoring to get our final answer. The first thing we're going to do is pull out a GCF. Okay, this has a GCF of 6. So we're going to pull that out. And when I do that, I'm going to be left with x cubed plus 5x squared minus 4x minus 20. And when I do that, I notice now that I'm left with 4 terms, I can use grouping. So I'm going to take these 4 terms, and I'm going to put them together into 2 groups. Now, I have my original GCF still. I don't want to forget that. But I'm going to take this, and I'm going to break it down. I'm going to group these 2 together, x cubed plus 5x squared. And I'm also going to group these together, my negative 4x minus 20. Now for here, it's going to work like a regular grouping problem. You keep your original GCF. Now look at your first group. I need to find a GCF in here. And as I do that, I notice I have x squared as a GCF. And that x squared is going to leave me with x plus 5. All right, and then the next pair, I notice that I have a GCF of negative 4. And when I pull out that GCF, I'm also going to be left with x plus 5. So to finish this off right now, this grouping part, I've got my original GCF. I have my factor, my x plus 5. And I also have this x squared minus 4. And hopefully you notice right here, this x squared minus 4, again, is our difference of squares. So this x squared can be broken down to be x and x. This minus 4 is going to be 2 and negative 2. So my final factored form has my original GCF. It has this x plus 5 And then it's got this difference of squares, so I'm going to have an x plus 2, and I'm also going to have an x minus 2. And that's my final factored form. 6 times x plus 5 times x plus 2 times x minus 2.